Ah, another draft science video. Yeah, I know. Yeah. Well, anyway, it's what it is. It's just the way it turns out. Sorry if that dissatisfies you, irritates you in some way for some reason. But that's the funny thing about this whole effort to communicate, and I mean it's just an effort to document in some respects my own progression through this understanding of what is going on, and obviously there's details, that are still in the fog. They're you can sort of see the pattern, sort of see where it's heading, but you can't quite make out the what exactly, whether it's a frog or a lizard or something. Um, and that's just because of the density, the the minuteness of all the little bits. It's like if I walk 10 feet and then walk back again. I could explain that as just being, well, when you're going that way, okay, you were consuming a bunch of the force, the field identity. Um, you transferred, you exchanged arrows stuff going that way for stuff going some other way that you released in some other way, and that was the equal and opposite reaction. And then when you came back, you did just the opposite. You basically exchanged the stuff you got rid of and took it back again, and it came back the other way. But obviously, all of this nuance that we're caught up in has so much more detail to it. Um, there's more to it. It's like the clock ticking is really simple on the outside, but it takes a lot of little gears and bullshit to make that happen. But the principle's the same. It's well, that's the principle's not the same. Um, just saying that yeah. So it takes a while to model that into um, some kind of Dr. Seuss version. Some sort of cartoon, simplistic identification of a problem and just some sort of illustration of it as it from beginning to end, a little narrative. And the narrative of the universe to be communicatable is going to have to be reduced to something like that. And that's sort of the process I'm in. I mean, the principles, I guess I would say, are gotten pretty solid. It's now just the idea of explaining how those principles, this gear does this and this one stops the thing from turning all the way and blah, 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 blah. How the mechanism produces that exactly, which I don't think is necessary. But anyway, so anyway, just thinking through some different things. So just, so many things to think through. Like, why is there so little participation in this conversation? And yeah, nobody really has an advantage in challenging me especially if they think I'm right? Because that's no fun, you know, to have somebody, you know, meet your challenge, so to speak. Um, so that might be one reason. And again, it's no advantage for somebody else to be sort of the foil or the guy that it's like somebody who helps somebody else win the gold medal or something. Being the trainer. That's just sort of an unrewarding job in a lot of ways because yes, you're just going to be the mechanism to somebody else's fame and fortune. So what good is that? So there's lots of I guess these are reasons why. I don't think everybody's an idiot. There's got to be somebody who knows something about physics who likes to talk about physics. Um, but again, I guess it's what's their advantage? What's their what do they get out of it? I guess I could argue that I don't know what I could argue. I mean, I have an interest, but there's no there's not much point because there's nobody else to engage, and I've sort of sought that with other people, but you can't really talk to them, you know, rationally. So people with other theories. So anyway, and I haven't heard back from this other guy who's really good at some of this. I mean, I just think he'd be really useful. Like I say, he does know the math part. seems to, inside and out, and that would be good, a nice advantage. And he's very cynical towards established physics in terms of they're lazy, and there's so many examples of that. And so I guess that's sort of what I want to talk about, the double slit some more, maybe. Or, well, not maybe, but really I just want to solicit some sort of, if you have a I was thinking of different ways to do the double slit or the single slit experiment. To sorry, to pull out information about what's really happening. Like what could you change? What would you fiddle with if you had the experiment in front of you and you could change things? How would you make changes to it to see what happens? And so if you have some of those ideas, I'd appreciate them. Obviously different than the ones I might illustrate here or describe. There was a couple that just were thought-provoking when I thought about them. So, yeah, I mean, that might be useful participation in some way. I think that's about it. That's all I want. I mean, that's the fundamental intent of the video, is just to see if there's anybody willing to do a little thinking about how you could arrange the experiment to find out the truth. There has been some effort to do that, and I think in some of those there is some glimmer of a flaw in this idea. There was one where a barrier was passed in front of the two slits, and essentially reducing it to a single slit and then another single slit experiment. But clearly that always causes an effect, because now you're just adding another diffracting element into the experiment. That's what makes this whole thing tricky, is that it's the idea of aiming photons is a little bit complicated, and that's what we really, that's a suggestion I had, is if it is possible for us to reliably get a photon to go from point A to point B and not go anywhere else, put a point B like on my forehead, and there's a photon producing element over there, and because of how it's arranged, the photon always hits point B. I mean, once you can do that, then you have a mechanism where you can just randomize where the photon goes, and you'll know exactly what slit it went through, how close it was to a surface, and all those kind of things, and you'll know exactly where it ended up. And so we'll have the trail of every one of these photons, and then we'll be able to say, that's what's happening. That, to me, is the ideal way to do this experiment. So just one of these things that is sort of irritating is that they always combine this quantum mechanics to photons, and then they just say, electrons are the same thing. And it's really not the same thing. The two are intimately associated. Whether you call one the penis and one the vagina, it doesn't really. They're connected. Okay, electrons are photon eaters and photon expellers, so they're connected. But clearly electrons are very different than photons, in that electrons are a collection of photons, and electrons have no necessary velocity. They can move at all kinds of different speeds depending on their configuration, and they are charged, which is they're very influenceable by electric and magnetic fields. They essentially they create the capacity to pass current through something. It has to pass through the electrons. The photons essentially move through their, I have a bunch, here you can have them. They pass them on to each other, and it makes it possible for this directional information to move from one piece of a bit of matter to another through these electrons. So anyway, so I mean, they're nothing, essentially they're very different things, and it's just to put them in the same category because they are capable of being affected by the same sort of structural circumstance. And this is just one of these, again, where you have a choice. They could have concluded one thing, or they could conclude the other thing. They could conclude that the thing is making the event happen, or they can think that the structure is making it happen. And if you think of it in a structural sense, then you'll understand that the electrons are doing a similar thing, creating a pattern. Because they are charged, then they're very sensitive to exactly the field that you're saying is affecting the photons, but it's not really affecting the photons, it's affecting the electrons that the photons are going to hit. And again, that's the thing we have to understand, and that's something I was just thinking about that I wanted to bring up in this video, because it was a thought I had, was about the fact that we're watching these experiments, or we're conducting these experiments in an atmosphere. There's the light is going through a transparency, and it's clearly a transparency. There's, what is it, 14 pounds per square inch of pressure on us right here. I mean, we're pushed together, not by, gravity is holding our atoms together, but the fact that our atoms are staying in a clump, an arrangement that they're in, the weak chemical bonds that they have, they're only allowed to have because we're under pressure, because there's a bunch of pressure pushing us together, and it's atomic pressure. So I mean, it's still the same. I see this is where it gets so annoying, is because it's a secondary expression of gravity. I mean, the bonds between atoms is a secondary expression of gravity, not a cursory, well, tertiary. So it's not as direct, it's the more indirect. But it's still, gravity is essentially creating those, the product is still transferred, all force, by gravity. But I mean, I'm just saying that it's not, what's the terminology to use? Well, it doesn't really matter. But the point is that we're in a pressure gradient, not of just gravity, but of gravity magnified by the effects on atomic structure. So gravity pushes the elements, the atoms, well, the bits inside the atom, of course, and those atoms now create pressure, on things that are in their way. And so that, I'm just saying, this is something to understand, is that the slit material has an atmosphere pushing on it. There's atoms against atoms, and that's sort of probably important to this conversation, because it's almost, this is my point. You could imagine, if you could imagine the atmosphere is what it really is, a thing, something, a solid. Just imagine gases were more solid. But they're clearly a structure that doesn't want to be in the condition it's in. It's being compressed from its natural state. The atoms don't want to be as close to each other as they are in the atmosphere. The atmosphere is made of a bunch of atoms that don't want to be as close as they are to each other. And they're being compressed. And so you can almost think of it then like a substance, like a something you could push, some kind of thing. And so just think of it as a clear, hey, both my needles broke off. Anyway, I'm going to remember that so I don't poke holes in myself with those little Sharpie things at the end there. Anyway, so you have to think of it like a clear substance, like a, and if so it's like the glass. I'm back to the glass argument again. When you change the thickness of the glass, you change the reflectivity of the glass through cycles. So as I keep going down, it goes from 16% to 4%, 16 to 0. So depending on the, how thick the glass is, I can almost reduce the reflectivity of the glass to 0. Which is, an interesting phenomenon, but I'm arguing that this has to do with the fact that the atoms have an alignment depending on the size of the vessel they're in. So if I'm changing the slit width, what I'm really changing is the atoms inside that slit. They're 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 going to arrange in different structures and different patterns based on the width of the slit, because the atoms have a fixed size and they have a desire to be a certain distance away from each other. Desire, you know what I mean. They have a mechanism that would tend in a free environment to produce a certain effect. See, I hate that you have to keep doing that. You have to keep restating it, and so somebody can't do a gotcha on you because you used a word you're not supposed to use. But anyway, that's just another side annoyance. But anyway, so I mean, I asked myself the simple question: has this experiment ever been done in a vacuum? Now, when they use electrons, that's why I brought up electrons. They do that in a vacuum because they usually use like the electron gun from a electron microscope or something, and all of that stuff happens in a vacuum. Um, and electrons are really bad in an atmosphere. If you shoot an electron through atmosphere, you're more likely to hit the atoms in the atmosphere and hit stuff, and it's, you know, getting your electron from point A to point B in an atmosphere is going to be really hard to do, where in a vacuum, where at least the atoms have been pulled out, it might be full of other electrons still floating about, but they're pretty farly spaced. Yeah, so you got a much better chance of getting an electron from point A to point B in a vacuum than you do in an atmosphere. You have almost, well, I'm not going to say no chance, but I'm just saying it's a much better chance. But we also, like I said, we just know from electron guns and all that kind of stuff that, you know, electrons hate being free almost. They really, really, really are not happy being free. They really want to find a home, a positive environment. Yeah, they want to find a positive environment. And they really hate associating with each other. So if there's other electrons around, they will run away. Um, so I'm just saying that using electrons in a vacuum is not even, there's no reason to think there's anything much related between an electron in a vacuum and a photon in a vacuum. Two different circumstances entirely. So I think that's important. Um, and to think of light going through atmosphere as being the same almost as a vacuum, I think it's just, it's not retarded, but I mean, it's just wrong. We just happen to be, we just happen to have, you know, this is another one of those circumstantial things where it could have been different, and the entire Earth evolution would have been different if the gases we were living in or on or through or using as medium were a little bit different gases, you know, opaque. You know, we wouldn't be able to do this stuff because there'd be this, the atmosphere would be cloudy and obscuring and scattering, and it would be a lot harsher in terms of being able to convey light or photons from one end of it to the other. But these gases are fundamentally transparent, so even in high density, they have clarity, so they transmit light. Their atoms are arranged in such a way that a photon goes in at a certain angle and it will come out at that angle. It will retain its identity in passing through these atoms, in not being absorbed. So when it's not absorbed, it's not ruined. Yeah, and it doesn't necessarily, it didn't have to be that way. That's all, I guess, the argument I'm making. So you can't really compare just because we feel the atmosphere as being nothing, that it's some kind of vacuum. It's not anything like a vacuum. So it does make a difference is all I'm saying. So that would be, anyway, it occurred to me that would be an interesting question. So I went out on the internet and tried to find somebody who asked the question, and somebody actually asked the question, which is really cool. But they got exactly what I get often. You know, they didn't delete his question, but they might as well have. But this is what you get, right? So it's this back to the stupid Stack Exchange place. And, you know, the guy asks a pretty specific question. if you do the double slit experiment in a foggy, smoky room, it seems like it's going to smudge out the interference pattern, right? Continuing in the other direction, it seems intuitive that a vacuum would lead to a crisper interference pattern than the space filled with air. Now, it's not just about the crispness, I would argue. That what I would argue is that clearly we know that atoms of atmosphere will diffract light. So when heat is radiating off of something, you can see because the atoms are being jiggled in a specific kind of jiggle, it's only certain kinds of frequency of movement will create this diffraction. So it has to be a speed of jiggle that will cause the light to be interfered with, and you'll get the blurriness. You won't be able to see clearly anymore because the angle of incidence, the angle going into the atom, will be different than the angle leaving the atom, because the atom will move while the photon is being transmitted through it. And so we already know that about our own atmosphere, so clearly movement of that atmosphere in certain ways will cause diffraction. So it could be understood that the atmosphere between the slits could be being affected by the slits, who are also being hit by photons that don't get transmitted. So you have to understand that most of the light, say the laser beams going in, there's a whole hunk of light that's hitting the material, which is vibrating the material, which in turn could be vibrating the atmosphere in between the slits. And that vibration could be what's causing the diffraction. I mean, this is a theory of a possible explanation. Anyway, is it experimentally? See, I mean, this guy couldn't have been clearer. I mean, this is a very well-written question. Is it experimentally known if the interference pattern is crisper in a vacuum? Question mark. And he gets the same dodge, from these experts. Fog or smoke interact with, this is the expert. Fog or smoke interact with light in two main ways: absorption and scattering. Absorption will reduce the intensity of the interference pattern. Well, duh, I think the guy knew that. Scattering can make light that was going somewhere bright send it somewhere dim. So it will wash out the pattern as you are thinking. Right, so scattering is another issue. Well, it's the same effect. It's just the fact that, if molecules are arranged in certain ways, they don't transmit light exactly as they received it. So if they're stretched or they're jiggling, they're not going to be very good transmitters of light. Clear air doesn't scatter light much. So that's very scientific, right? Clear air doesn't scatter light. I mean, if you ended right there, well, that's just wrong. Yes, it does. Much. So, I mean, that's just a qualification that's just that's just saying it the wrong way. But anyway, so your problem should be almost as, so your pattern should be almost as sharp as in a vacuum. He just made that up, right? So the guy asks, is there anything experimentally known? And the guy answers with, well, I'm just going to pull some shit out of my ass and speculate that atmosphere isn't much different than a vacuum, so yeah, it's just better, it's just clearer glass. When that's not a good answer. So then the guy, harasses him a little and says, is that to say the vacuum will in fact be a little crisper? In fact. And then the guy says, yes, but probably by an amount hard to notice. Probably. So it's a fact, probably. Maybe. Possibly. So that's it. So that's the end. That's all you get. Pooh. I mean, nothing. Useless. Anyway. So, that was one effort. How come it didn't close? Well, I might as well leave it open for now. So then I went looking around for some other stuff, and it's just so hard to find this stuff, and that's very irritating. So I found a thing that's doing the double slit thing here, another explanation of it, and they're using a machine gun and blah 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 and explaining, and they do the same damn thing, which is so irritating, because this is all over the place. this same lie is just all over the place, and nobody seems to be at all upset, except me, that this is the foundation of physics. This is the foundation of all this quantum woo-woo is based on this experiment, and this is how dishonest they are in describing what's happening in this experiment. I mean, understand, entanglement, all this stuff that grew out of this wave idea of a photon is all of it's built on this experiment. And so here you go again. They show it this way. Waves come in, and then little wave pops out. And what do they show? The same old single lump. No diffraction, none. And as I've illustrated in videos, the math says that these little secondary maximas are only 4% of this primary one. Now you can go back to those 2 laser experiments I showed you. I think there was 2. And there's no way the secondary maxima is only 4%. So, you know, that would mean that you could have 50 of those to make one of that's the primary, and there's no way the primary is 50 times brighter than the secondary. But anyway, this is just another one of the things I wanted to just illustrate, though. So anyway, so they did the one hump this way, so when it's open this slit, then that's one hump that way. So they did this is just the same fricking lie. You know, it's called Feynman's double slit experiment. You know, this isn't the truth. This is just a canard. It's just a lie. And I mean, a lie. It's just so wrong. It's just so frickin' wrong. But this is what they do. This is what the physicists believe. These Al-Kahari guys and the rest. This is what they believe is the truth. Apparently, and it's not the truth. And like I said, I'm sitting here saying, look, you know, if this is how unattentive to detail they are with the most famous experiment. This is how unattentive they are to detail the most famous experiment in physics. Then just imagine how perhaps unattentive they have been to detail in all of their accelerator results, and all of a sudden their presumptions, their announcements. We've discovered the, you know, blah blah quark, the, you know, upsy downsy quark, the, you know, insy outsy quark, the blah blah blah. You can just imagine if this is how much they care about detail and getting it right. You know, what is all this crap based on? What is the Standard Model based on? If it's based on this kind of interpretation, just flatly and plainly wrong. And it's been around for it's been sitting there for 100 years, drawn wrong, and they keep letting physics draw it wrong. And I'm the bad guy. Yeah. So anyway, I did want to bring up another point, damn it, and I just forgot it because I was talking some more. Yeah, damn. I mean, relevant to this somehow. You know, the wrong drawing of it, the intensity of it, so it has to do with the oh yeah, it's the light, the source, so that's another issue that's just so irritating. Because the math is basically based on these waves coming in would not be round waves. You know, the math is based on perfectly coherent light, so it has to be like laser light. And that's what I think is kind of strange, is that the math is based on laser light, but the laser experiments are the ones that indicate there's something wrong with that math, because these secondary maximas are not 50 times weaker. I just don't think they could possibly be that much weaker. But anyway, I mean, well, 4 into 100 is 25, right? 5 into 100 is 25. That's 20. Yeah, so 4% would be, you know, maybe I got that number wrong. Well, 20 times, 25 times weaker. Yeah, 4 would be 25 times weaker. Yeah. Yeah, no way. But anyway, So what am I going to remember? So yeah, this is a key thing, right? I mean, the original experiment was done with light that went through an aperture, so it was light that was more intense at the center and less intense on the periphery. And the laser beam technically is creating light that's fairly even across the whole plane. And there's nothing in the math that accounts for the type, the source light. So there's nothing in the math that establishes, are you talking about laser light or aperture light? Nothing. So they do all this math, and they don't ever, they just talk about it as if those two experiments are identical. And those two experiments are not identical. Using an aperture that spreads the light does not create consistent, coherent, colonnaded light. It's not what it produces. So, it's, what can I say? And we already know that from Newton's rings. That is another example. So besides not being at all of the same intensity in different places, we know from the fact of Newton that that small aperture is also going to create rings, diffraction, and that there's going to be dead spots in the light. Especially when we're using monochromatic light, because those dead spots aren't going to be filled with other colors of light, which I guess our eye compensates for, our brain compensates for, because that's happening. When you're viewing the world, is your eye is creating intensities, stronger and weaker intensities are what it's receiving based on diffraction. So the image isn't perfect, far from it. But I think our brain fixes it. But anyway, it doesn't really, that part isn't nearly as, well, it's all important though. But that's just a fact. I mean, again, this is another fact that this wave coming in, if it's an aperture, it's got a diffraction pattern built into it. So it's got little dead spots going through here. There's no accounting for any of this. I mean, these are fundamental, important details, and they have not either identified them or they've drawn them explicitly wrong. And why is that okay? I'm obviously saying this is way short of what physics should be. And I guess it's just that physics has become dominated by showboating. Isn't it all amazing? They're all phantasmagorical fantasy writers writing fantasy books. And that's what they've converted this science into. And even the serious scientist guys out there, the ones who can do all this strangled math and understand this stuff a little deeper, they're not doing anything to stop it. They're not calling foul anywhere. They're not throwing flags anywhere. Just very disappointing. Okay. What next? So I wanted to do the atmosphere thing because that's sort of the important one. Yeah, so I did that. I just pointed out that it is in an atmosphere. A real vacuum would be interesting. I mean, a vacuum doesn't pull out free electrons and other things like that, so they're all going to still be there. And I think, so there's still some dirt. But this is sort of the argument I'm arguing about what's causing lensing in the cosmic thing. That it's not gravity that's bending the light. That it's the clutter around gravitational objects, and especially things like suns, which are expelling a ton of energy. They have a lot of crap around them, a heavy atmosphere that you're looking through, and that's what the light's traveling through, and it's getting diffracted by that atmosphere of expelled particles. And it would be interesting to see that lensing is substantially different in a quieter place in the universe where you have a heavy gravitational body that just happens to have cleaned everything around it and isn't producing, isn't on fire. Which, is hard to find, because I guess that's the definition of one of those black holes, quote unquote. But anyway, it does seem like there are places where this lensing would be more appropriately understood. And I just think there's places where it should be that it isn't. Seems like one of the places it should be that it isn't, is that many galaxies have this dead space. They have a noisy little center, then they have a little bit of a dead space, and then they have the spirals. And it's that little dead space before the spiral seems to me a place where this lensing argument, you might get somewhere. But anyway, it doesn't matter. That's another subject altogether. Well, I mean, obviously it's related, because it all comes down to understanding that photons don't do stuff. Photons aren't affected by anything except, okay, what happens to them. It's like a planet will fly through space and it's perfectly fine, doesn't care about anything until it gets caught in a solar system. Then it can go off in some other direction. It's probably not even a great example, just because photons are so much more unaffectable than a planet. Because, my argument is it's all kinetic, and the photon is just a pattern so if you understand the kinetic balls, that bounce back and forth, and you just made a field of kinetic balls, you'd understand that, if I poked, and made a noise from one side, it would just transfer through the balls. It wouldn't be the actual ball that went through that mechanism, so to speak. There would just be the noise that would go through. The vibration would be passed on from one to another to another. And in a kind of way, photons are in that kind of medium. They're just the photons. It isn't about the individual little rock moving across space, because all the time it's getting hit different directions. There's other noises, but the primary noise, its noise will keep going straight. You can't change the direction of the noise. The noise can't be moved unless it gets caught in one of these gravity wells that spews it out in some other direction. But there's no other way to deflect a photon than to partially absorb it, to have it go into a gravity well and pop out in a new direction. But you just can't bend it. So anyway, I'm just saying that the fact that that's fundamental to my theory is a fact. So yes, I'm arguing from that point of view that yes, my theory breaks if you can move photons. At least the part of the theory saying that photons are just gravity with a frequency. They're just gravity with a frequency. They're nothing special. That a photon isn't have any identity at all. That it's made of two quanta. Like I said, a single photon is really two quanta. And they're just separated by a distance. And that's all they are. So they're just two little gravitons separated by a distance on the same vector. That's a photon. And that all photons, red photons, green photons, blue photons, doesn't matter which color photon, they're all made of exactly the same thing. And the only thing different about a red photon and a blue photon is how close they are to each other in the vector, in how they're being transmitted. Alright, so that's probably enough. So anyway, a couple of little experimental things I thought were good. So first, let's see if we can find this experiment in a vacuum with light. Not electrons, but with light. Second, I thought of heat. It'd be interesting if you heated the slits, slowly. Just increase their temperature. Do you get a difference in pattern? A much difference. And then a real simple one is just to have one slit a little bit bigger than the other slit. So do the two slit experiment with one slit that's 10% bigger than the other slit. And then or 20%. You could do it with changing that percentage. And obviously that would give you some indication of what, is the light on this side from this slit and the light on that side from this slit. I mean, it would give you an indication of where this is what side is causing it. And I also thought of teeth, putting little tiny teeth on a slit or something, just a marker of some kind that would indicate what slit it came from. Based on the, you would see a reflection of that pattern on the other slit. So something to give an indication of top and bottom or side to side. What slit, what edge put the photon over there. Like somehow that edge is what brought the photon over there because it is reflecting that pattern. But that's a little trickier to do because obviously you can't, photons are going to be smaller than any teeth you put on any structure. But I'm just saying any little identification marks couldn't hurt. But anyway, so enough of that. Yeah, so those are the three I thought of off the top of my, without giving it too much thought. But obviously I've had other barrier ideas, like put a barrier between the two slits, the gun. Just so you're pretty sure the gun can't possibly, with a barrier, you're kind of, it has to go through that slit, or it has to go through that slit. Maybe you could have something that just tilted, so every time you fired the gun, it's like you're blocking one of the slits, but you're blocking it with a divider. You just have a divider between the gun and the slits, so that when it's in this position, there's no way for the photon to get to the left slit, and when it's in the other position, there's no way for it to get to the right slit. And that way you know what slit it went through. I'm just curious. Yes, that'd be enough. Yeah, I think that's enough for this video. But it is all so undercooked, to just realize that, it's obviously to my advantage that this is so bad. In the sense that I'm coming up with a counter theory, and and then they all challenge you with the quantum mechanics is the most proven theory in the history of mankind, but it's the most predictable, blah, blah, blah. All this crap. And you see what it's based on. You're just saying, how can you, this is just bold talk. The fact that you've identified that there's a probabilistic outcome, yes, we all agree that the outcome exists. Yes, there is a pattern. That's not the argument. We're not arguing your math. Well, we're arguing how you're doing the math, because we're arguing the variables create the result. So, yes, the wavelength of the light matters. Yes, the distance between the slits matters. Yes, all that is agreed upon. But why those variables affect the pattern is the question. And the contention that the photon splits in half and creates waves, whereas I'm saying, no, the photon goes through a slit, it goes in one direction, it hits an electron, and the electron diffracts it. And it does that for a specific reason based on the circumstances of distances and all this kind of stuff. How much atmosphere is between the slits, how many atoms across it is. All of those things affect the condition of the electrons that the photon is interacting with when it's going next to a surface. When a photon flies next to a surface, it's flying through a field of rubbish, a field full of electrons. Even in a vacuum that would probably exist, but clearly at least what a vacuum would demonstrate is that these aren't atoms, okay, the electrons in atoms that are affecting the diffraction, where like in atmosphere, well, I guess it's ions often, which aren't complete atoms, which makes this all quite complicated. Whether an atomic nucleus can absorb a photon and emit it, I don't think there's any reason theoretically to think it can't, but I just mean that traditionally it's kind of understood that electrons are doing the manipulation of photons. But that's an open question, I guess, from my perspective. I don't have enough knowledge on that specifically. So anyway, now that's probably enough, right? Yeah, it's probably enough. Alright. It can't be like a hydrogen ion. There's no electron, right? I mean, a positive hydrogen ion doesn't have an electron, so it probably can't diffract light because it probably can't absorb light, right? Okay, anyway. So till next time. And such. Yeah, that's enough. So yeah, I'll try to get back to, I have to get to writing, right? That's what it comes down to. I have to write some of this crap, and I just don't like writing. At this particular period of my life, I find it an inadequate way to communicate. Yeah, anyway, till next time.